Good morning, ma'am. Myself B. Balaji. I am from Triple E department. Now I am going to explain about interconnection of two port networks in series, parallel, and cascade configurations. And introduction to two port network, ma'am. Two port networks are linear electrical circuits defined by two pairs of terminals. These networks can be analyzed using parameters such as impedance, admittance, and hybrid parameters. Understanding interconnections of these networks is circular for designing complex electrical systems. So here we can observe that, ma'am, two port networks in introduction, example, and parameters were there. And here there was two voltages and two ports networks and two currents were there, ma'am. And coming to series configuration of two port networks, here there are in a series configuration, the output port of one network is directly connected to the input port of another network. In this sentence we can observe that in a series configuration, the output port of one network is directly connected to another input port of another network, ma'am. And the total impedance of the series connections is the sum of the individual impedance. The configuration is useful when designing circuits that require additive effects on voltage or current. Here the cased connections and series connections, parallel connections, and Hind connections are there. Coming to voltage and current in series configuration, the current through each network is series is the same, while the voltages across each can differ. The total voltages across the series configuration is the sum of the voltages across each network. Series configurations often lead to voltage division, which can be critical for circuit functionality. Coming to parallel connection of two port networks. In a parallel connection configuration, both networks are connected to the same input and output terminals. The total admittance of the parallel connection is the sum of the individual admittance. This setup is advantageous for applications requiring shared voltage levels and differing current paths. And voltage and current in parallel configuration. Here we can observe that the voltage across each network in parallel remains the same, while the current can vary. Then the total current flowing into the parallel configuration is the sum of the currents through each network. And parallel configurations are commonly used in power distribution systems to ensure reliability. Here you can observe that V2 equals to V3, E equals to V1 plus V2, I equals to I2 plus I3. Says case configuration of cascade configuration of two port networks. A cascade configuration involves connecting multiple two ports networks in a series arrangement. The output of the one network becomes the input to the next, facilitating complex signals processing. The approach is prevalent in communication such system, while signal amplification or filtering is needed. Analyzing cascade networks. The overall transfer function of cascade networks can be obtained by multiplying the individual transform functions. Analyzing cascade networks helps in understanding the cumulative effects on gain and bandwidth. Engineers often use the configuration to achieve desired specifications in a modular manner. And coming to comparison of series, parallel, and cascade configurations, series connection emphasize voltage scaling, while parallel connections focus on current sharing. And cascade connections leverage the advantages of both series and parallel to enhance the performance. Each configuration has unique applications and considerations depending on system requirements. Here we can observe the differences between series, parallel when current, voltage, and equal resistance. and these were the formulas. Practical applications of interconnected networks. Series configurations are commonly found in voltage dividers and amplified circuits. Parallel configurations are essential in load balancing and redundancy in power systems. Cascade configurations are utilized in multi-stage amplifiers and filters designed for improved signal qualities. Conclusion and future directions. Understanding the interconnection of two-port networks is vital for modern electrical engineering. Ongoing advancements in technology will continue to refine these concepts for emerging applications. Future research may focus on developing smarter interconnection techniques for complex systems. And this was the explanation about the interconnection of two-port networks in series, parallel, and cascade configurations. Thank you very much, ma'am.